Hey folks, welcome to Static Analysis Shockingly Awesome with me, Dr. Goldberg. I am a full-time independent open source maintainer. I focus on these kinds of tools in the JavaScript TypeScript ecosystem. Locally TypeScript ecosystem, we'll see later. I'm also the author of the TypeScript provided a Microsoft MVP for development technologies, and most importantly, my favorite food is okonomiyaki, which I had in Alaska. We'll pull that. Maybe next year we will do this in person. Anyway, most of my career, I have been like this. More literals, please. I love the liter. I love feeling that awesome sense of warmth and satisfaction when the tool tells me, you could do this better, or hey, you might have a bug. It's a nice feeling for me. But I understand, not everyone gets the same reaction. Some folks feel a little less positive when the linter gives them a squiggly and they then have to spend a bunch of time figuring out. Now, I categorize a lot of folks, including sometimes my reactions, under the lovely phrase fun, fear, uncertainty, and doubt. Fear, red editor squigglies, something is broken. Oh no, uncertainty. I don't know why it says it's broken, and I certainly haven't been able to find out. That's the time for that. But doubts, I know my code works. I'm just going to silence the linter, ESLint disable, TS ignore, whatever. Sometimes that is the right approach, because we are all overrushed under budgeted developers, but if possible, I prefer not to fun it up. Instead of funning it up, I prefer to approach static analysis and to do it with love and certainty and appreciation. Today we're going to learn all sorts of cool stuff about static analysis. Some you might know, some you might not, tools you may or may not be using, and I'm really excited to dive in with you. So let's get started. Static analysis. The arts of good squigglies. Why so squiggly? Static analysis is tooling that scrutinizes your code without running it. This is in contrast to dynamic analysis, tooling like unit tests, end-to-end tests, and mutation tests. Typically, static analysis exists on the spectrum from speed to power. You have the really fast forms of static analysis, such as format, prettier, deeper, and so on. And then you have the slower but much more powerful ones, typically the type checkers, like TypeScript and Flow. In the middle, you get the area that I spend the most time in, which is the linters. They are slower than a formatter and dumber than a type checker, but they can be quite useful. And we're going to go through especially linters, but also all three of these tools today. And I'm going to start with the linters. What is a linter? Or the more common question for all these tools, have I sworn at this thing before? A linter is a tool that runs a set of discrete checks on your source code. A set of discrete checks. Each of those checks is typically also called a rule or a linter rule. Each of those rules looks for one particular code pattern or violation. It may report any number of those per file, and each of those reports or complaints may optionally contain an autofix for how to correct for the issue. For example, ESLint comes with a really nice built-in rule called logical assignment operators. Logical assignment operators is able to look at syntax like this, friend equals friend or me, and let you know, hey, fun fact, there's actually a better way of doing this. A nice little clean new syntax introduced to JavaScript over the last few years. The assignment can be replaced with an operator assignment, friend or equals me. Look at that, nice little new syntax. A lot of the rules end up either catching bugs or introducing you to cleaner ways of doing things. And if catching bugs or writing less code, either that is of use to you or of interest, then you might enjoy getting started with ESLint locally. The 3 steps I typically recommend for folks who are getting a new project or recreating the ESLint config for an existing project is to first install ESLint as a dev dependency, then run the @ESLint/config configurator that the ESLint team wrote. It's this nice little tool that will walk you through setting up an ESLint config for the kind of project you have. And then you can run npx ESLint dots. Dot or period is a directory path to the current directory. So you're in essence telling ESLint to run on the current directory. Good stuff. Now, if we were to look at your ESLint config, hopefully somewhere in there, there is a line like this one. Extend ESLint recommended. Each of ESLint's rules may be configurable on its own, but it's quite useful, and will save you a lot of time, to start with the recommended rule set. This is telling ESLint to enable its default settings for rules, turning on a whole bunch of built-in ones with particular settings. This is nice because the ESLint team has worked with a lot of folks over the years and come up with a general set of recommended starting configuration free rules that are mostly applicable to most projects most of the time. Now, most is the key word there because there's no one ESLint config that will work for everyone. So while the recommended rule set enables a lot of rules under the error severity, meaning fail to build, give a red squiggly, red terminal text if a violation or report is found, you may, likely eventually will, want to discreetly configure your own settings on top of those. I recommend trying this out just to see what happens. At the very least, you can try setting a built-in recommended rule to warn. Warn says, instead of giving me a red squiggly or text and failing to build, I should instead set yellow text, yellow squiggly, and don't fail to build. Warnings can be quite useful if you are getting started with a new rule and you have very many failures, and you don't have time to fix all of them. But the downside of warnings is that they don't fail to build. So left unchecked, they can kind of accumulate over time in your code base. So I recommend also running ESLint with -- max warnings, set to as low a number as possible, IPv0, which says if I see any warnings more in total count than that number, I should in fact fail the build. Now, setting a rule to warn instead of error or turning it off altogether, setting it to off in the ESLint config, is a very big setting. It changes it for your entire project. But sometimes for rules, you may want to disable them only in one little area. Let's say only on one line or only in one file. And you can do so with ESLint disable comments. These comments tell ESLint to change its settings for a specific line or area, block, file even. For example, there's a built-in rule in Node console, which a lot of folks prefer because they don't want random console logs. They prefer to use their own logger if possible. But you may have area of code where you just want to get a log, and you might then want to use ESLint disable next time. But then, similar with warnings, you might find that these pile up over time unnecessarily. So I also recommend running ESLint with -- report unused disable directives. That says, if I have any of these ESLint disable comments or directives that don't actually do anything, give me a complaint. Which is actually really nice. Because oftentimes you'll find that you may need it at one point in time for certain area code, but eventually that code gets refactored, changes, no longer would produce an ESLint complaint. So reporting that unused disable directive means you can find unnecessary comments to remove. And then if you run ESLint with -- fix, then you can have it automatically remove those comments for you. It's quite nice. A couple more ESLint settings tips. Most extensions and editors have equivalents to what I'm going to show you. But in VS Code, which is my preferred editor, the way to recommend the ESLint extension is with a .vscode/extensions.json file. That means anyone who opens your project will have a nice one-click button saying, hey, we have recommended extensions for you. Click here to install them. And vscode/settings.json, you can enable under your code actions on save for your editor, source.fixall.eslint true, which says autofix all possible ESLint violations or complaints on save. I quite like that because personally I enable quite a few ESLint rules in my projects. Everything from detecting unused code to sorting my imports and object properties when possible. So having the tool do that for me instead of having to manually fiddle around with my lines is quite nice. Now speaking of auto-fixing, I mentioned I wanted to touch on formatters. A formatter, again, is not the same thing as a linter. I'm going to dive in now onto that. Structurally speaking, the way a formatter, a tool, is written is very different from how a linter tool is written, at the very least in the JavaScript TypeScript ecosystem. A formatter is a tool that goes very quickly all in one pass. It's very fast. It doesn't find or fix bugs. It doesn't really understand the logic of your code. It just touches up white space, new lines, putting things on a new line versus the collection to the same. Whereas a linter runs a set of discrete rules. Each rule, generally speaking, only understands one source file at a time and does not have visibility to the other rules. Which means while it can find logic, it does fix for logical issues, it's slower because it's got a lot of separate rules from it. And each rule has to handle all of its own edge cases, which actually makes the linter not particularly suitable for formatting code, because you might have two lint rules for formatting that conflict with each other. That, let's say, one adds a semicolon, and that would trigger maximum line length in another rule, which would then autofix, which would trigger another rule. So it's very slow to use a linter as a formatter. And while ESLint does include a lot of rules that have existed for a while around formatting, such as the indent rules, semi, xlen, and so on. And they do work generally. I personally, and many other lint maintainers, do not recommend using them. Instead, many, not all, but many of us recommend using dedicated formatters such as Prettier, which will, again, much more quickly and much more reliably format it. Now, there is the added cost here of we have a second static analysis tool to learn to love. So if you really want to use ESLint for formatting, there is a new project called ESLint.style, headed up by the very excellent Anthony Fu. Highly recommend it if that is how you want to format your rules, format your code with ESLint. Because ESLint and the project I work on, TypeScript ESLint, we're deprecating our formatting rules pretty soon. So you're going to have to use this one. I get all excited and passionate about this. Okay, we're about halfway through. Let's talk about my favorite subject in the world. Talk about TypeScript. Woo. TypeScript, why won't you tech Twitter or X or whatnot? Shut up now. Well, TypeScript is a superset of JavaScript. We sometimes call it. We also sometimes call it JavaScript with X. The reason why we like it, for those who haven't played with it much before, is because while JavaScript is a good language for expressing values, what we put into our variables, what we declare as our classes, and so on, it doesn't have a built-in syntax or tooling set for the intent behind those values. There is the option to use comments. There's a standard for JavaScript comments called JSConf, but it's not built into JavaScript. There's no actual specification. There's no tooling in JavaScript to enforce that your comments are accurate. So TypeScript provides, through a few different tools we'll see soon, some nice ways of describing your value's intent. The intent behind the value. And those tools I like to describe in 4 different layers, because they're all different. The first layer isn't even a programming tool, it's just the idea of a programming language. TypeScript, the programming language, is a language that describes all the syntax you know and love from JavaScript, plus some additional syntax that lets you describe your intent, type annotations, interface declarations, and so on. On top of that, you have the first of the 3 tools we'll show here, the type checker, which is a tool typically written in TypeScript that reads in files and reports unlikely bugs or mistakes or mismatches. So the type checker will read in your TypeScript config, your JS files, your GS files, and will just let you know in your terminal little messages about what it thinks might be wrong. The type checker is typically run by the TypeScript compiler, which is a tool that, in addition to running the type checker, also runs the TypeScript transpiler, which is a tool that takes in your JavaScript TypeScript code and outputs the equivalent of JavaScript. Now, different ecosystems use the terms compiler, transpiler, and so on differently. This is how I refer to them for JavaScript. And lastly, we have the language service, which is a tool that, unlike the Pilot type checker, specifically runs only in one environment, an editor, such as the TypeScript playground online or your editor of VS Code. The language service will typically run at least the type checker, sometimes also the compiler, and it's what turns those programmatic complaints into red squigglies or little text errors. Let's take a look at a quick code snippet before we get more excited about TypeScript to explain why we really love this thing. Without type checking, it would be very difficult to just look at this MyButton class or component and know whether we're using it correctly, this function. For example, let's say it's in something like React or Preact. If we have another component breaking into it, it's very difficult for us to know, did we use it right? Is on-click required? Were we supposed to put that there? Maybe we did call it right for now, but what if we actually got the type wrong, like we passed a string instead of a function? Without TypeScript, there's not really any programmatic way for us to know this until we run the code. But if you were to rename the files to TypeScript extensions or run TypeScript, you might get a complaint like, hey, you forgot to pass on click. There was a structured parameter prop there that you didn't pass. And then if you enable the tsconfig or TypeScript configuration option, no implicit any, it would let you know, hey, you told me there's this on-click thing, but you never said what the type actually is. Which would then encourage you to fill in the type and say you write an interface and that on-click is a function that returns nothing, void. Which would then mean that TypeScript would let you know, aha, you said this is a function, but you actually provided string. That's really useful. I like TypeScript. Similar to how a formatter and a linter are not the same, we should also note that a linter and a type checker, ESLint and TypeScript, are very much different, but not the same. Structurally, they're implemented very differently. A traditional linter, at least in the JavaScript space, runs a set of discretely configurable rules. Each of those rules typically only use one file at a time and doesn't know about any other rules. Which means because those rules are standalone, they're each in their own little lane. A traditional linter is much faster than a type checker in JavaScript. But the type checker is harder because it builds up a full understanding of your code base. It knows all the types, even if one file depends on other files and npm packages, which means it's harder but slower. Now, I've seen a lot of user pain from folks who aren't fully sure when they see squigglies, whether they're from the linter or the type checker. And I think in a lot of editors, that's probably because they show up as the same squiggly color by default, which I've always personally found irritating and inconvenient. So at least in VS Code, I recommend, I'll show how to do this in a couple slides, changing it so that your ESLint squigglies, your linter squigglies, are a different color than your type checking, your TypeScript squigglies. And I'm actually really trying to decide. I authored the pull request that did this for VS Code. You can set, for example, ESLint.rules.customizations, all of them, little asterisk, severity 1 instead of error. This doesn't change your builds, it's just how editors do things, but I found this to be very useful when trying to do large refactors and you're in progress and there are a lot of solutions. One last tip on VS Code before we talk about TypeScript and some more. VS Code comes with its own version of TypeScript. It's just each version of VS Code has what's the latest at the time. But your projects might have different versions. So I recommend also setting TypeScript.SDK to say for this project, use the version of TypeScript I have in my node collections. Okay. Let's talk about TypeScript and ESLint together. ESLint is the standard JavaScript linter. It's very pluggable, meaning you can give it additional parsers for new syntax. You can give it plugins that provide new rules. And TypeScript is a language that builds on top of JavaScript. So by default, ESLint doesn't understand TypeScript code. In order to make ESLint understand your TypeScript, you use a project called TypeScript ESLint. And typically you use at least 2 packages from this. The TypeScript ESLint parser package tells ESLint how to read that TypeScript syntax. And then the TypeScript ESLint plugin package provides a bunch of rules for ESLint that work well in TypeScript code. Let's look at a starter ESLint config. I'll note that we in TypeScript ESLint do have docs for this, but just to get you a snapshot. Voila! This is a good starter ESLint config for a TypeScript code base. Note the emphasizing color parser and plugins. We're saying use the TypeScript ESLint parser to parse code, and load in a bunch of rules from the ESLint plugin under TypeScript ESLint. In addition, much like ESLint core, we also provide you a set of recommended rules that we have found to work on most projects most of the time for most devs. Also, I really like sorting, so let's just sort this config real quick. That's my personal preference, you don't have to. One change we made earlier this year, actually in 2023, was that we used to have stylistic consistency recommendations in our recommended rules, and developers really hate that. Devs have very different opinions on style. So we split out our stylistic rules into their own preset config. So now we have stylistic alongside recommended that you can opt into. And I'll just show you an example of a generally speaking stylistic rule we provide. Prefer as const. If you haven't used TypeScript or type assertions in TypeScript before, this may be very fun for you to discover. In TypeScript, you can use the as keyword to tell TypeScript a different type of program. In this case, the name property on the B variable would be inferred as string. If you really want TypeScript to consider it, let's say Holland, for some reason, you can say, no, as Holland, rather than as string. And our prefer as const rule would let you know, you silly goose, there's a shortcut for that, as const. So much like that, or equals from before, this rule doesn't find a bug, it just helps you learn new TypeScript syntax. Now, I mentioned that a type checker is very powerful, but we've only looked at using lint rules with syntax so far. And that's because traditionally lint rules, ESLint values, don't understand the types of your code. But if we could let them understand types, if we were to make them really nice and type form, we have a new class of lint rules that are actually much more powerful than traditional ones. And if only that were possible, yes, it is, of course it's possible. I'm going to show you how, because this is this awesome new classification where we combine linters and type checkers, 1 plus 2 on this chart, to these type check lint rules. And I'll show you an example of one that finds dead code. We have a rule in TypeScript ESLint called await mutable. Await mutable lets you know if you're awaiting something that isn't mutable. In JavaScript, mutable is the term for an object that has a not-that method, such as most commonly a promise. I would be surprised if more than 0 or 1 of you have ever written await console.log, but fun fact, awaiting nothing or awaiting a promise that returned void or awaiting undefined just does nothing. So our rule will let you know, hey, you can just remove that await. Now, on its own, that doesn't strike me as super useful. So let's look at a more deep example. This is some JSX code. I think it's React. Let's say React, maybe Preact. And I'll just give you the shortcut. You don't have to read it all. There is an unnecessary wait here. One of the advantages of a linter is it reads your code much faster than you, so you can find things very quickly. Since I only have 5.5 minutes, I'm just going to blaze through this. One way to fix this await would be to, well, notice that it's awaiting it on click. So what if that on click is changed to return promise in the type system? That's one way to appease the linter. Ultimately, though, what if we realize on click is never asynchronous? Because then we could remove the await, which means the running state, well, true, click, false. There's no need for that running state to change, which means this on-click disable function can just be removed, which means there's no need for the running state in the first place because it's always false, which means but disable if it's false can be removed. And by the way, for half the time now, that's not even the right way to make but disabled ARIA disabled is the better way to get accessibility, which means we can remove a third of our code or more due to the power of linting. Yay! So cool. Yes. Now, one note. Type check linting is slower than regular linting, so we don't turn it on by default. If you want to turn on these awesome things, there are a few steps you have to take. First, extend from the recommended, if you have a stylistic, type check presets. There are supersets of the non-type check versions. Then also set cursor options project true in your ESLint config, which tells the type of ESLint tooling to find the closest TS config or type of config file for each of your listed source files. Also, by the way, root true is just a good setting in your ESLint config. It tells ESLint to don't look higher, such as in your root directory for ESLint options. And that's how you enable page activity. Now, there are a few ESLint plugins I want to quickly end with because ESLint and type of ESLint are just the start. There's a whole world out there. So just blazing through these, I highly recommend if you ever have a chance to try it out. ESLint plugin deprecation will let you know if these are complaints. If you're using an API or something in code that's been marked in the JSConf at deprecate tag, very useful. ESLint plugin ESLint comments will let you know that you kind of messed up your disable directives. For example, you can enforce, if you wanted to, that every ESLint disable that operates in more than one line has a corresponding enable, so you're not accidentally disabling a rule for an entire file instead of just for one area. One of my favorite ones is ESLint plugin JSDoc. This will let you know if you mess up your JSON comments, like if you describe a parameter that doesn't exist. And one rule, I wrote this one, I'm very proud of it, will let you know if the description for a parameter doesn't actually provide any new info. Param ID, VID, I think we gotta figure that out. ESLint plugin Markdown will let ESLint run on code blocks in your Markdown files. For example, this is a snippet Markdown that has a TS code block with an unnecessary variable. ESLint plugin Markdown is just run ESLint and other rules in that. Very cool. ESLint plugin N, short for node, is the node specific plugin. So for example, if you import from some package that doesn't exist, it'll let you know. And then one of my favorite ones, ESLint plugin Perfectionist. I've started using this. It forces sorting of everything, and I mean everything. It's very configurable, but it'll let you know if, let's say, you don't use alphabetical, you said you wanted to. And yes, it will autofix for you. So you don't have to do that manually. And lastly, ESLint plugin regex, so regular expressions, will let you know if you have common mistakes in regexes, such as security vulnerabilities. They can find DDoS, regular expression duplicated denial of service attacks. For example, this one is an exponentially increasing computation. It's at least a character repeated at least one times. This is a common cause of security complaints on GitHub. And okay, that's too much. That's a lot of complaints. And I want to emphasize my last bit. I understand it's very unfortunate that there's so much out there to the point that it can actually be really painful. There's so much to learn, so much to configure. As excited as we all are about all the cool things we can do with Linting, just going through all these things, part of me is dying because I know how much annoying it is to figure all that. But at the same time, it has upsides. There's a lot of cool stuff in it. And because a lot of this is very new, we're still learning the best ways to do it. Which means in 5 years' time, we're going to be way better at Linting because we've tried out all these new things. So if you have the time and the energy, I recommend try all these things out. Try out effective ESLint type tools. Try out ESLint one. It's a good time. Anyway, let's recap to go through some resource links. Everything is online. I post my slides on joshgoldberg.com, so you don't need to screenshot this. We intend ESLint are an open source project independent from any one company, so we encourage you to check this out, read our docs, contribute your time, money, to choose anything you can. We appreciate it. I wrote a architecture book, which is now translated to Japanese. I'm very excited about that. Anyway, lastly, I'm Josh. You can find me as Josh Goldberg on basically every platform. This has been an absolute pleasure. Thanks, everyone.